We have two binomials, 2x plus 3, 5x plus 4. And if we FOIL these, you will notice that we are going to take the 2x and multiply it by the 5x. So we're going to take these two terms here and multiply them. And so when you do that, 2x and 5x give you 10x squared. That's my first terms there. Then I go to my outer terms. 2x times 4. That's going to give me 8x. 3 times 5x. That's going to give me 15x. And then 3 times 4 is going to give me 12. And then if we were to simplify this particular one, we would combine those two middle terms here. And we would get 10x squared plus 23x plus 12. This is different than what we've been doing if we were to factor this, because there are no factors of 12 that would add up to give me 23. Okay? There's no factors of 12 that add up to 23, because we don't just have to consider the 12 anymore. Now we have a leading coefficient. For everyone that we have been factoring up to this point, our leading coefficient has been 1. In fact, if you look at your bell work, you had 1x squared, 1y squared, 1t squared. And so when you thought about the FOILing of this, you only had to consider the last term when you thought about the middle terms. But now all of a sudden, we have extra numbers in here that we have to think about. The first term also affects your middle term, okay? And so there's two ways to do these, and I'm going to do them both ways so that you can see both methods. Product A, product is A, product is C. So what they're telling you is this is a product and this is a product, right? But this right here is the sum of the products. So we took factors of 10 to get to the 2 and the 5, factors of 12 to get the 3 and the 4. But then it was a combination of those factors that made these up. And so when you start unfoiling this type of trinomial, then all of a sudden you have more factors in play than what we've been looking at, okay? And you have to figure out how they match up, all right? So let's look at this first example here. They want us to factor 6n squared and 23 plus 23n plus 7, all right? So we don't just look at factors of 7 because we have a leading coefficient. It is not 1. And so now I'm going to have to list all my factors of 6, which are 1 and 6 and 2 and 3. And then I'm also going to have to list my factors of 7, which is just 1 and 7. And now I want to figure out how these add up to 23. If I were to pair the 2 to the 1 and the 3 to the 7, that would give me 2 plus 21, right? That's going to work. But that's because I actually know what's going on here. There are a multitude of possibilities, right? Let's look at all my possibilities. What if I were to start at the top and say 1 and 1 and 6 and 7? That gives me 1 and 42, right? That does not work. So what if I were to do 1 and 7 and 6 and 1? That gives me 7 plus 6. That also doesn't work. So you see how you're going to start having these groupings that have to make sense, all right? You have to pair them up correctly. And so like I said at the beginning, if we were to do 2 and 3, 2 times the 1, 3 times the 7, that gives me my 23. Those are the pairs that I'm looking for. So I know my first terms are going to be made up of the 2 and the 3. My last terms are going to be made up of 1 and 7, but what order? So what I typically do here is I start with my first terms. I know that's going to be 2n. I know that's going to be 3n. All right? And so I know 2n and 3n, that gives me 6n squared. We're good. All right? I need the 2 to multiply by the 1. So if you go back to the FOILing, and here, if I want the 2 to multiply by the 1, 2 is an outer term. It has to multiply to an outer term. So my 1 has to go over here. All right? My 3, if I want that to multiply to the 7, the way I set this up, my 3 is an inner term. So it has to multiply to an inner term. So the 7 has to go there. Does that make sense? In this case, they're both positive. So positive and positive. My factoring here then would be 2n plus 7, 3n plus 1. All right? That's the first way to do it. list all of your factors, group them, and then see how they pair up. There is a second way to do this. This is not shown in your examples, so you may want to write this down. So the last thing we ended on before we did our game was we did factoring by grouping. Okay, factoring by grouping. And so you can actually set these up to be a grouping problem, but in order to group, I need 4 terms. So if you do it this method, what you're going to do is you're going to take your first term, 6, and you're going to multiply it by your last one, 7. So I'm going to say 6 times 7, that gives me what? 42, all right? Now I want factors then of 42 that add up to 23. What are factors of 42 that add up to 23? All right, so 2 and 21. Does everybody agree 2 times 21 is 42 and 2 plus 21 is 23? All right, so what we're going to do is we're going to break up this middle term. We are going to leave the first term the way it is. We are going to leave the 6n squared. We are going to rewrite the middle term to these. It needs an n because I need it to add up to 21n. So I'm going to say plus 2n plus 21n. And then I'm going to leave this last term alone, plus 7. All right, so now I have 4 terms, and I'm going to factor this by grouping. If you remember, grouping just means group the first 2 and group the second 2, okay? So I'm going to group the first 2, and I'm going to group the second 2. What is in common between the 6n squared and the 2n? 2 and n, right? So 6 divided by 2 is 3. I took out one of the n's. 2n divided by 2n is just 1. All right? In between the 7 and the 21, my common factor here is 7. And I'm left with 3n plus 1. And then when you finish out the grouping, you take your group that is in common. That's 3n plus 1. And what's left over is your second group, 2n plus 7. Now, if I compare this to what I just did prior, then you'll see we have the same exact factoring. All right, the difference here is that your C is negative. If you use the method that goes across, it's the same concept. If you're grouping your things, then you have to consider a positive and a negative when you group. So if I were to do my factors of 7, and I have like 1 and 7, and my factors of 8, Then when I group these to see if they add up to get to my center term, I have to remember that one is going to be positive and one is going to be negative. The other tricky part of this, if you just do your grouping, is that when you multiply, make sure that you multiply the two that will cause it to be negative and you multiply the two that will cause it to be positive, because that's very important that you know which is positive and which is negative. Now, if you do it the second method, you don't have to worry about it. You can just say 7 times 8. What is 7 times 8? 56. And in this case, it's negative because my last term is negative. Factors of that subtract. One's going to be positive and one's going to be negative to give me 26. So 2 and 28 multiply to give you 56, and I subtract to give you 26. Which one needs to be negative? The 28. Now here's the deal. If you don't want to remember to group behind a negative, you can always put your negative first, but sometimes you're going to have two of them. All right, so I'm going to split this up. My first term stays exactly the same, 7x squared. I'm going to break up this middle term to be a positive 2x and a negative 28x. Positive 2x, negative 28x. And I'm going to leave this last term alone, including the negative, negative 8. Okay? And then I'm just going to factor by grouping. Group here, group here. I grouped behind a negative, so I need to change this last sign. What comes out of 7x squared and 2x? What comes out of it? What comes out of it? Factor out of it. So no numbers. What about variables? X. So I'm left with 7x plus 2 minus here. What comes out of 28 and 8? 4. That's 7x plus 2, which is how it should always work out. 7x plus 2 is my first group. X minus 4 is my second group. So again, it's going to work out exactly the same. All right, questions on that? In this case, one's positive and one is negative when you do this. All right, so go ahead and try A, B, and C for check understanding 2. So honestly, when you're handed a trinomial to factor, this is literally the first thing you look for, but they always give us examples without them to begin with, okay? And so when you have something like this, before you start, you know, trying to multiply 20 and 35 and get, you know, some 700 or whatever and try to factors of 700 and all that stuff, you need to always look to see, can I take something out of all of it first? Because one, if you don't, then you're going to have not completely factored it when you get to the end. One of your groups will be able to have something taken out of it. And two, you'll make it harder on yourself because you have much larger numbers here. So the first step in factoring is always, always, always look for the common factor. And so I'm going to look at my 20, my 80, and my 35 first to see, is there anything I can take out? And is there something that goes into all three of those? Actually, first. So I'm going to take the 5 out. And I'm actually doing this because I know I'm going to have to continue factoring. 20 divided by 5 is 4x squared. 80 divided by 5 is 16x. And 35 divided by 5 is 7. All right. And again, you can do this either way you want. They're all positives. So you can do your 1 and 4 and your 2 and your 2 and your 1 and your 7. Or you can multiply the first and the last factors of 28 that add up to give you 16. All right. And so once you do this, you know, this is when it's going to be like 2 and 14. But you can do the same thing. If you want to factor by grouping, you can. You can go ahead and factor, separate it out. Or you can start pairing these up, however they're going to pair up. All right, if you factor by grouping, keep that 5 on the outside the whole time you're doing it so that you do not forget it as your final answer. And when you get to the end, you can drop your brackets. You just have a 5, and then you have your 2 binomials that are left here. All right, so the only difference is when you do something like this, you're going to have a number on the outside there when you get to your final answer.